2010 graduate of Montana Tech with a Bachelor of Science in Mechanical Engineering. Following graduation, Mr. Gollehon spent his time in the petroleum field with an emphasis in drilling operations. In 2015, he started his company, Ross Engineering and Design, PLLC, which specializes in advanced drilling technologies. The creation and deployment of his brainchild, Accu-Scribe, is changing the industry standards for scribeline offset calculations that replace the traditional earplug method, while significantly increasing safety and efficiency of directional drilling everywhere. Accu-Scribe is the first solution in over 50 years to address scribeline offset precision, and will be an essential piece of the next era of petroleum engineering and rig of the future. Brian.
Good afternoon. There's been some awesome presentations here today. Couldn't be any more excited to be a part of this. Thank you, Kevin. Thank you, Todd, for putting this on for us. I appreciate it very much. Like Jess said, so I started my company about two years ago. Accu-Scribe is the very first system we're going to deploy to the field. We've actually done some testing in North Dakota. The prototype 1, what you see today, will be prototype 1.5. I'll show you the new addition to this system here coming out in a couple weeks. So to start off, what is the scribeline offset? Let's bring you guys out to the rig. So it's a glorious day in North Dakota. We'll go to February and 2 in the morning, minus 20. It's a very, very unique environment to be out there. But anyways, right now we're picking up a BHA. This is a BHA, a conventional bottom hole assembly. It's comprised of a drill bit, a mud motor, and an MWD. The drill bit drills through the rock in front of it, right? So it's usually a PDC bit in North Dakota. They do extensive research with these. That drill bit is the start of a bottom hole assembly. Behind that is a mud motor, so it's a progressive cavity positive displacement pump. What that means is if we flow mud through this mud motor, a turbine will turn and generate torque through a transmission. So we don't have to spin the drill pipe to spin this drill bit. So if we held this bend in a direction for a while, eventually we can go from vertical to horizontal directional drilling. Behind that is a very intelligent piece of computers, which is called the MWD, or Major Well Drilling System. Can you help me get this cap on? Never mind. Okay, so inside of this are computers. There are magnetometers and accelerometers. They read the Earth's gravity and the Earth's magnetics. Above this is called a poppet valve. So when we flow mud through here, this poppet valve creates minor pressure spikes in the mud system. And on the surface, we can read these pressure spikes as ones and zeros, it's binary code. When we set these computers inside, we orientate these internal computers, the internal scribe, to an external scribe. It's imperative we know which way that bend is pointing.
What is the scribeline offset?
So a scribeline offset essentially aligns this MWD high side to the mud motor high side, which is the top of the bend. Just to say, for example, this MWD was pointed to the north and the mud motor was pointed to the south, that offset would be 180 degrees. So every time this pop-up valve sent us information and said, hey, I'm pointed to the south, we add on that 180 degrees and we say, your mud motor is pointed to the north. We do this every time in industry. So every time we put a BHA together, a conventional bottom hole assembly, we take this reading. Right here is a description of this laying up. So this is in the derrick. Generally, these bottom hole assemblies are 90 feet long. This is 30 feet long. So 3 times as long as this, we take this reading. So if you get this wrong, here's some major consequences. You may have to re-permit your well because you drilled the wrong way for too long. You may have to plug back. So you missed your curve and you want to go back and do it again. Very costly. Or you gradually come back into zone after you landed your curve. which ruins your downhole physics for the rest of the lateral. Another part or a consequence of misscribing is the personnel. Today in industry, all of us are on the rig floor. There's 4 of us, 2 directional drillers and 2 MWDs taking this reading. Any drillers out here doing work on the rig? Okay. There's 18,000 feet of pipe, 4 people out there, and 2 roughnecks and a company man taking this reading. It's pretty cluttered. So we need to get these people off the floor. Additionally, if you get this wrong and do not disclose this to your company, as per their policy, they will terminate you. So you could lose a very nice job because you took one math calculation wrong. And also, if you do find out it's wrong, you have to question your own personal integrity. So when I was out on the rig and I thought that there might be a scribeline issue, I gave it 2 slides, 2 good slides. So we hold a tool face in the direction we want to go. We hold those tool faces very good, so straight north, and it does respond well as a straight north, and we just say maybe it's a bit deflection, maybe it's a formation. But after 2 slides, you say, you know what, I had some really good tool faces, and this is telling me that my back calculated slide is off 30 degrees. Then we start acknowledging the BHA scribeline offset and the issues with it. Okay, so we're going to go through the old way. This is how they do it on the rig. So the last 50 years, we have never changed this technology. People have had some decent ideas, ways to figure this out. Nobody has deployed anything to help fix this problem. Today, we're going to show you history of directional drilling. First off, we're going to do the old way. So Jess, would you please pick somebody from the crowd? So I'm going to give you guys some updates while they're doing this. Nobody has a picture of this. If we would like to see the scribeline offset again, we're getting back out of the hole. You're 16,000 feet out, you're drilling the wrong way. You're tripping 16,000 feet of pipe to see this thing. If there's a convention, we have an outer diameter tape where we take this, the scribeline offset reading. You'll see Jess pull it out here in a minute. It has to be upside down. I was having a rig training a brand new hand that just got back from days off. I was like, hey, this is how you do scribeline offset. And I had mine right side up. Thank gosh, the other MWD came behind me and said, hey, your tape's upside down. All of these human errors are in there. I just went across another service company's directional drilling practice standards for scribeline offsets, and it specifically states that directional drillers have left or right side bias. In every connection, they have to adjust for their left or right side bias all the way up the bottom of the assembly. So if you have 6 pieces in between here, and they bring the scribes together, what I'm saying is they're taking this gear plug, this line, Kirby just looked down the side of this piece and marked it, right? So gear plug, high side line, the equation is you take the outer diameter of the pipe, get a ratio of distance between the 2 marks, times by 360. So it's a percentage of that 360-degree circle that they get a scribeline offset. To date, these things cause significant amount of issues. So if this tape is slightly skewed, if you're reading the wrong mark, just can you show them the tape really quick? Very finite markings. All of these can cause issues. It can slip. So you have invert running across this BHA, you can slip. 4 people have to take this reading also because it's that important. How you guys come along? Doing good? Okay. So what Jess is going to do also is verify it with her. So he's going to look down the side and say, hey, this looks good. Your marks looks appropriate from here. Can you guys imagine doing this at 90 feet in a snowstorm? It's pretty tough. We got the fishing lure lights is what we do to identify this in super harsh weather conditions. It's atrocious. It's full of errors. And is talking about what Kevin Broussard earlier today, when you're talking about dogleg severities, right? This is your dogleg severity system. This is what you go in the hole with to directionally drill. We have all of these people standing out there in unsafe conditions, in an unsafe environment, taking this reading, and there's issues. Scribeline error offsets are not uncommon. So now we're going to fix this with our new system.
Introducing Accu-Scribe, the first flawless, high-speed, automated scribe line offset. In drilling for oil, the directional accuracy of your drill bit's trajectory is everything.
Okay, thank you, Coach Green. Couldn't have said it better myself. Okay, so to the right, this came to me at 4 o'clock in the morning. This is a target housing. Tyler, would you kick on the laser first? So how we align this is we shine a laser on the side of the MWD, and we align it with a very precise system. Now would you kick on the lights for us? We have, the blue light is the high side of the MWD, and then every 90 degrees we have green offsets with it. This helps us with our proprietary software. Additionally, I was talking with Albert, and they're like, well, how do we know it's on the right mark? I was like, gosh, I'm gonna have to put more cameras on this thing. Like, the cost of this thing's gonna go out there. I was like, wait, why don't I just put a mirror on the inside of this thing and reflect the line in these pictures that we're gonna take down here? So now we have a 360-degree mirror that we can see what line this is on. If you have on the wrong line, you don't have to trip out of the bolt. We just set up this image and say, hey, this is our actual line with this camera, this target housing, and do it again. Pick up off the bottom, not tripping 16,000 feet of pipe out of the bolt. Okay, down here is the camera housing. The camera housing has 2 cameras. 360 degrees is what we need to see visible of this target. What we do is, this is the neatest technology ever. These are wireless, they have their own wireless network on them. So how we take these people off the rig floor is we give them their phone, which most every directional driller or hand out there has their phone on them, and a Nikon app that allows them to wirelessly connect to each one of these cameras. So now we've taken all 4 of these people off the floor. We can put 2 people back to bed because now we have the accuracy. So the off-tower shift is now sleeping. And if you're about ready to go and drill a curve, you want every ounce of sleep you're going to get because those can get very ugly very quick. So now we have people inside the doghouse, out of harm's way. The driller, as you guys see on Captain Ness's presentation, that driller has 6 screens in front of him, plus all of these hands to manage. And now he has 4 people on the rig floor that some are may not be trained in a blowout situation. Now they're out of his way. And he can communicate to them without communicating through a talk box. It's a radio communication system on the rig. It's very difficult to hear what they're trying to say. So what we do is we take pictures of this and we put them into our software. Right now, while I'm going to analyze this offset, I'm going to let Tyler talk to you about some of the advantages and cost savings. Tyler and I worked together in North Dakota on Neighbors B6 for several years. He was also one of my very first investors of this system. Before it was ever a product, before it was ever tested, it was an idea. He stepped out and helped me out to get here today. So Tyler, here you go.
All right, so something we could all agree on that one of the main linchpins of a successful drilling operation is your ability to place your wellbore accurately within zone. So what Accu-Scribe does is it gives you the confidence to put the most accurate VHAs you possibly could below your rotor table. A more accurate scribe line offset allows you to, it affects your wellbores. You have less dog legs, fewer variations, all around better accuracy, right? So that lends itself to lower torque throughout the well. Lower torque allows you to get more weight on your bit as you progress into the well. More weight on bit takes you into increased ROP. Increased ROP gets you less days on well. Less days on well, reduced costs, right? So a small example of reduced costs would be my time on the rigs. I personally witnessed directional having scribe line issues while drilling the curve. So as a result, we ended up landing the curve a little bit low. So immediately into starting the lateral, we had to slide up back into zone. Puts a dog leg immediately outside your chute. It absolutely wreaked havoc on our torque level. This has happened multiple times. Puts torque levels through the roof for the remainder of the lateral. Well, to try and fight that, we end up pumping slug after slug of lube down hole, like every connection, 2-3 slugs of lube. So in an instance like that, your cost savings in lube alone would cover the cost of running this system. And essentially, Accu-Scribe is the cheapest insurance you could buy to cover a multi-million-dollar project.
Thank you. So what you guys saw is importing images that we took. So we wirelessly transferred them and imported them into our software. This is my scribe line offset. Jess, are you running around here? Yeah. Okay. Would you please let me know when you guys got your scribe line offset?
389.2.
389.2. I got a 287.94. Riley, would you tell us what the scribe line offset is?
It was 288.
288. So, right here, right in front of you guys, I had no idea what that scribe line offset was. Jess had no idea what that scribe line offset was either. Kirby, thank you. We're within 6,000ths of a degree, 600ths, excuse me. Pretty incredible. If you took their error and put it at a 90-foot bottom hole assembly, it's extensive. Service companies have been touted to accept 30-degree errors in scribe line offsets. Incredible. So when we're looking for the best dog legs, the least amount of wellbore deviation, the most accurate plan drilling out there, this reading is imperative to an accurate bottom hole assembly. So I talked to you guys about the next prototype. This is our target housing here. Thankfully, the guys down at Creating Tool and Instrument here in town and Fathom on Seattle 3D printers got me this product as soon as possible. This target housing is roughly about 15 pounds. We also have a secondary fall restraint system that attaches to here. We have batteries in here, lithium-ion batteries that are very tolerant to cold conditions. So we're out there February, something breaks down, this unit's up in here for a while. It has 8 hours of run life in minus 20 degree Fahrenheit life. So hopefully we can get your hurdles. This is the new camera housing. Let's see if it gets a little closer. Sure does. I'm gonna go back really quick. So that is a dual latch assembly. We've converted it into a single latch assembly right here. Explosion-proof housings. We do not want to be in any way, shape, or form responsible for an issue on that rig floor. Safety is our #1 priority. And each one of these units can fit on 8-inch pipe all the way down to 4-inch pipe. Same unit, their inserts are interchangeable. I don't know if you guys can see, but we'll be back out there in a little bit. These inserts you can replace, and they're both the same style. So one can use the other one's inserts. So this is the future of directional drilling, is remote directional drilling operations. The people are in Houston, they pick up the tools in North Dakota. The people in Houston oversee 3 to 4 rigs. Why they do this is because they find the most elite directional drillers they have on their rigs, and now it's standardized. For those 4 rigs, they get the same answers. They get the lowest dollars, they get the fastest ROP. This system fits in perfectly. Say you have a company man that is unsure of a scribe line offset. We can deploy this system to them. We were out in North Dakota, there was a drilling class there. In 2 runs, we had them putting this system on and accurately placing it on the lines they needed to. We can teach the people out there how to run this system. After that, Schlumberger and Precision are working on something called the rig of the future. The rig of the future is the driller picks up, puts in, dials in what they want for their slide, and they say go. And a computer program runs the drilling rig. So now you have an accurate system that knows what tool face it's getting, and it's going to do the best job it can. If we have a bad scribe line offset, it's going to have no idea it has that. So somebody is going to have to provide accurate data to make these computers accurate. So here today, we can give you that accuracy. There's additional savings. So if you guys have we get out of the curve and we have a scribe line issue and we have a 2-degree drop, you may not be able to drill the rest of your lateral. If you're missing frac sleeves in these production zones, that's a lot of money. If we're reducing your slide times because your dog legs are better, if your accuracy is higher, we're saving you money. Insurance, we can prove that your rig's now safer, and we have archived data. The first time ever in the history of directional drilling, you have a picture of this. You can reevaluate it. So at 6 o'clock Friday night, you're out to dinner, you're wondering what's going on in the rig, you get an email saying, hey, here's your scribe line offset. Now you know the rig is tripping in the hole, running the system in the ground, and if you have an issue, you come to our server, we can all review this data simultaneously.
Accu-Scribe, unparalleled innovation and accuracy, value, and safety.
A couple things. One, I'd like to say thank you to my family. They mean the world to me, and they've got me here today, and my friends, and the support team that I have. You guys are second to none. Thank you to Montana Tech for giving me an education and the alumni support that has got me here in front of you guys today. It's been a long time coming getting here. 2 days ago, our patent was on file. It's 43 pages long, 15 pages of figures. It's massive. It's very rewarding to be here, and I couldn't do it without this school. So I'd just like to say thank you guys so much for your time. If you have any questions, I'd love to take them now.
Are you also taking a picture of what you're setting your motor offset to?
Absolutely.
Because, there's two things that always go wrong with the rig. The scribe, and what did they actually set that motor at? 187, 212.
Yep.
Be so good now that you take a picture of that, you might as well take a picture of that, you'll always have evidence of that. So that's really good.
Yeah, it will be in prototype number 2. Yeah, or shortly after. Absolutely. So we'll have pictures of everything.
Exactly.
So you know what happened on your rig. Additionally, what I did not mention, all of these pictures are going to look very similar. We're going to have a digital readout, a serial number associated to your rig, that time, and what the BHA was in that well. So these all look the same. Well, you have a serial number that you can verify that's independent of these cameras. And the cameras will also have a picture stamp on them as well. So these are all coming down the pipeline. Go ahead. Ian.
Yeah, also, we're running a lot of our rigs now remotely. So this is going to be amazing because, less people out there. There's only 1 or 2 people out there anyhow. And for them to check the scribe is going to be great because they're running it out of a central station in Calgary or somewhere.
Absolutely. And you can do a post-scribe. Now that you have accuracy, now you can evaluate torque. What happened in between our BHA? Let's take a pre and post scribe line offset, back calculate through our threads, and say, hey, this is what happened. This is how much torque this BHA saw. This is data. This is downfill data. Thank you very much. Anybody else? Perfect. Thank you. Oh, go ahead.
I was just curious if, it seems like such a good idea now, it could be such a concept. Is there any reason why they haven't done this in the past? Like,
Every time we've had a scribe line offset, or we go up to the rig floor, I'd ask myself the same exact question. Why? Yeah.
Okay.
The God's honest truth. One night I laid down to rest. I absolutely needed some sleep. And I let 3 people go up and take this offset. When you go into a command center, it should be TV's on, somebody's cooking, a lot of BS. Like it's a really good, vibrant environment. This place was dead quiet. I had no idea what was going on. I went up and slid and went the wrong way. I come back down and I said, what happened last night? Oh, well, we had an argument over the scribe line offset. I said, I'm 100 feet away. You can call me up to the floor. I just needed to lay down. It was 6 hours of paperwork and email chains and communication to get that through. Literally, probably lit the fire behind me today. We're fixing this right now. And that's what I've done. Anybody else? Thank you again very much. Appreciate it.